All right, so here we are with write and solve systems of equations. This corresponds to TEKS A2I and A5C, both readiness TEKS on the Algebra 1 STAR test if you're playing the STAR TEKS game. Number 1 asks us to find the solution to the system of equations. Now we can tell because there's no quadratic terms, there's only linear terms. In other words, there's only degree 1 terms here, that these are both linear equations. As a result, we know that if I were to put these in slope-intercept form and graph them, they would just be 2 straight lines on a coordinate plane. And where they intersect, if they intersect, where they intersect is the solution. So the intersection coordinate, x comma y, of the intersection of these 2 lines when plotted is the solution to the system of linear equations. However, we don't have a graph this time. So how do we solve for x and y of the intersection point of these 2 lines without having a graph? And there's a variety of methods that we can use. The 2 primary ones are called substitution and elimination. And the one that makes the most sense here is elimination, specifically elimination by addition. Let me show you exactly what I mean. If I just draw a line underneath these 2 equations and then put a big plus symbol here. And then what I like to do is to separate these out into columns. This seems to help students a little bit. You notice that negative 7x plus 7x equals 0. Okay? So in a sense, adding them cancels it out. So now I've gotten rid of the x variable, okay? And now I can solve, since I only have one variable, I can solve for the y variable. Well, what's negative 4 plus negative 3? That's going to be negative 7y. Okay. So negative 7y equals, and then we add negative 44 and 16. Well, over in side work, we can do 44 minus 16 and just make the answer negative. And I need to borrow. This becomes 14. 14 minus 6 is 8. 3 minus 1 is 2. And it's negative. So the difference there, or the sum of negative 44 and 16 is negative 28. And I think we can start to see where this is heading. So now, let me zoom in a little bit here. Now, all I need to do is get rid of the negative 7. And so what I'll do is divide both the left and the right side by negative 7. Okay, why would I do that? Well, because now I can cancel out these negative 7s on the left, leaving y by itself, and y will equal negative 28 divided by negative 7, which negative divided by negative is a positive. 28 divided by 7 is 4. Therefore, y equals 4. Okay, so I just found part of my answer. You know, if my answer is over here, and I'm saying that this is the intersection point, and that's going to be a coordinate pair, okay, I have the y value, 4. Okay, so now I need to know what x is when y is 4. I can take either of these 2 equations, the original ones, written in black, and just plug in 4 for y, and then find x. The bottom equation looks easier. It has smaller numbers, fewer negative symbols. So we'll say down here we'll say given y equals 4, okay, and then we're going to write, let me just so you can see it here, given y equals 4 and 7x minus 3y equals 16, we can write 7x minus 3, open parentheses, close parentheses, equals 16. Okay. And then that open parentheses, I'm going to put the y value that I am going to substitute into this equation. So I'm going to put 4 in here. All right. So now let's work it out. So the next line would be 7x minus 12 equals 16. And now we're trying to isolate that x variable, so we would just add 12 to both sides. Over here I kind of get to cancel out the 12s, and 7x comes down here. 7x equals whatever the sum of 16 and 12 is, and that's going to be 28. Okay, so now dividing both sides by 7, I see that x equals 4. Okay, so now going back up here, you see we now have both of our coordinates 4, 4. X and y are both 4. Now, how do we check this? Is there a way to check this? Yes, there is. There's a way to check it graphically, but there's also a way to check it without graphing. And that is to just take that same equation and plug in 4 for both x and y and see if the statement that results is true. So to check, okay, we will just assume that x and y are both 4. So now we have 7, open parentheses, close parentheses. I'm doing this equation here, the bottom one. Minus 3, open parentheses, close parentheses, equals 16. All right, so this is my check. And now inside, I'm going to put 4 for x and 4 for y. Okay, so we have 7 times 4 is 28. Minus 12. And we're really asking a question here. Sometimes it's helpful to put a question mark above the equal sign. Is that equal to 16? Okay. Well, 28 minus 12 is 16. So we write 16 equals 16. And there's actually a mathematical property called the identity property of equality, or IP, that you can write to sort of prove that. And whenever you prove something to be totally correct, you can end your proof with a black box like this. Okay. Now there's also the graphing method of checking your answer. You won't be able to do that using Desmos or the TI calculator in the STAR test, but let me show you what it looks like when graphed, so you can see that in fact these two lines intersect at 4, 4. Okay, so here we are looking at both of these equations graphed, and when you hover over the intersection point, you see that indeed they intersect at 4, 4. So that's another verification that you're correct, and it also provides you that visual understanding of these two linear equations as a system merely mean two lines that cross somewhere, okay? If they were parallel, they would never cross and there would be no solution. If they went right over one another, that would mean they were the same line and they have infinitely many solutions. But in this case, they just cross at one point, so that they have one solution in the real number system. Okay, so here we are with number 2. Now, on number 2, there isn't such an obvious way of just adding the equations up and having something disappear. Back up here in number 1, the negative 7x and 7x kind of just stood out, and so we can immediately eliminate them. Now you're going to have to learn some of the rules and some of the privileges and freedoms that you have to take with these equations. For example, you are free to multiply one of the equations by whatever number you want. That would help you. Think about what would help you here if you wanted to eliminate the x value. You could multiply, for example, the top equation by 2. So if I multiply every term of the top equation by 2, and distribute that 2 through every term, notice that my main goal of getting this to be negative 10x, so I can add and eliminate the 10x, it works. But you have to multiply every term by 2. Just keep that in mind. Even the term on the other side of the equal sign. So here we go. Now, when you do this, unfortunately, you have to rewrite everything. But when it happens to be the top equation that you're doing this to, you can avoid rewriting the bottom equation by simply placing the result of this distribution underneath this equation. You'll see what I mean. So 2 times negative 5x is negative 10x. So I'm just going to write negative 10x right here. This way I don't have to rewrite both equations. It doesn't really matter which one's on top and which one's on the bottom. Okay, 2 times negative 5y, that's going to be negative 10y. Okay, equals 2 times negative 30 equals negative 60. Okay, so now I can proceed, right? I can draw a line and I can put a plus symbol here. Again, I strongly recommend this columnar method. This will help you immensely keep things separate. So right away I see, oh, okay, so now I can eliminate the x values are gone, and we can just add up plus 3y minus 10y. That's going to give me negative 7y. Okay, equals negative 63. Okay, and now I think you know what to do. We're going to divide both sides by negative 7. And the left side negative 7s cancel out, leaving y hashtag forever alone. So y equals, we've just found the y value is negative 63 divided by negative 7. So negative divided by negative is a positive. 63 divided by 7 is 9. So negative 63 divided by negative 7 is positive 9. Okay, so I just found half my solution, right? So over here, in my solution, x comma y, I found y is 9. Okay. So now the question is, what is x when y is 9? Now, which equation looks easier? I'm going to go with the bottom equation, fewer negative symbols. So what is x when y is 9? Okay. Zoom out a little bit. Okay, so this is kind of part 2, right? So when the question is, what is x when y is 9? Okay. I just want to, make that's the question we're trying to answer. So let's take this equation given (10x plus 3y equals negative 3). And y equals 9. Okay, what have we got? We have 10x plus 3, and then open parentheses, close parentheses, equals negative 3. And what goes in the parentheses? 9. All right, the y value. Okay, so let's work it out. So this gives us 10x plus 27 equals negative 3. All right, so I'm trying to get that x by itself. So the first thing I'm going to do is subtract 27 from both sides. These equal signs lined up. Subtract 27 from both sides. Cancel out the 27s on the left. I have 10x equals, and then negative 3 minus 27 is negative 30. Dividing both sides by 10. Cancel, cancel. I find that x equals, and then negative 30 divided by 10 is negative 3. Okay, so what that means is back up here, our intersection point, or the solution, is negative 3, comma 9. So this is the solution, okay, which is just the intersection. Okay, of those 2 points. And let's see if those 2 points really do intersect at negative 3, comma 9. Okay, so here we are looking at the graph, and if we go hover over the intersection point, we see that's indeed what happens. The two equations intersect at negative 3, comma 9. Always remember, how could you have checked that without using a graphing calculator? How would you know you were right? I'll just run through this again. Checking your work should be something we do for every problem, but we often skip this part. But you should check your work. So check. What are we checking? Okay. If x is negative 3 and y is 9, okay, then, and then we'll pick an equation. Let's pick this easier one. Then 10x plus 3y equals negative 3 should be true. Okay, that's a claim, right? It's a hypothesis. Okay, well, is it true? So let's test it by substituting in negative 3 here for x. We have 10, open parentheses, negative 3, close parentheses, plus 3, open parentheses, and then remember y is 9, so put the 9 in there, close parentheses, and let's see if that works out to be negative 3. Okay, and that's sort of a question, right? Is it? Okay, so 10 times negative 3, that's negative 30. And then 3 times 9 is 27, so negative 30 plus 27. Does negative 30 plus 27 equal negative 3? Again, question mark. Well, negative 30 plus 27 is negative 3. So negative 3 equals negative 3 by, what was that property called? IPE, the identity property of equality. So we can say by IPE, this is true, and we've proven it. Okay, so we can put this black square. Okay, so you checked your work. That's how you check your work without having the access to a graphing calculator or computer program. Okay, and number 3, we're asked to solve the system of equations using elimination, which is actually what we've been doing for the past 2 problems. So the only difference here is they didn't stack it for us, so we have to kind of rewrite it. We need to make sure that we put the x's over the x's and the y's over the y's, and the equals over the equals, and the constants over the constants. So we'll just start out by writing the first one. Negative 5x plus 8y equals 5. And then underneath that, Well, let's think about that for a minute, right? So if I write underneath that x minus 2y equals 1, I'm not going to be able to eliminate anything, right? So before we write anything underneath that, let's mess with this equation to make it something that I can add to negative 5x to eliminate you know what? We'll do it for the y value since we haven't done that before. We'll eliminate the y value. So what would I need to multiply by negative 2 in order to make it disappear when added to 8y? Oh, I'd need to multiply the whole equation by 4, right? So over in side work, let's show that. So we have x minus 2y equals 1, okay? And what I'm going to do is I'm going to multiply the whole equation by 4. Okay? And I'm going to distribute multiply that 4. All right, so what's the output going to be? Well, it's going to be 4x. And then 4 times negative 2y is minus 8y. It's going to allow me to eliminate the y when I add. And then 4 times 1 is 4, equals 4. Okay, so now I can bring this and put it underneath this, and we'll just be able to add and make the stuff disappear. So we have 4x. This time we're eliminating the y. Minus 8y equals 4. Okay, and we're going to add. So we're going to add. And this time I'm eliminating the y value, so I'm not expecting the x's to eliminate. I should have negative 1x here, or just negative x. And then I have this completely disappearing. So negative x equals 5 plus 4 is 9. So if you don't understand the intuition here, if negative x equals positive 9, then positive x equals negative 9. If you don't understand that intuition, that's okay. We can do negative 1x, negative 1 times x equals 9. And then divide both sides by negative 1. Okay, and I'll get x equals negative 9. Okay, so I found part of my solution, didn't I? So here's my solution. And the x value of that solution is 9. Okay, so now I'm asking a slightly different question than the other questions we've answered, which is, what is y when x is 9? Okay, so now let's ask that question. What is y when x is 9? Okay. Well, let's figure it out. So it looks like the easier equation here is this one. for plugging in x. So x minus 2y equals 1. So we'll say given x minus 2y equals 1, and provided that x equals 9, okay, we have this open parentheses, closed parentheses, minus 2y equals 1. In that parentheses, I'm going to put the x value of 9. See, now I'm going to solve for y and find out what is y when x is 9. Okay, so the first thing I'm going to do is subtract 9 from both sides. And that cancels out these 9s. And so now I have negative 2y equals 1 minus 9, which is negative 8. Okay, so now we're going to divide both sides of the equation by negative 2. Cancel, cancel. Y is by itself, and y equals negative 8 divided by negative 2, which is positive 4. So now there's my solution up here, 9 comma 4, the intersection point of those two lines. Okay? And folks, I see I made a mistake here. Most of you probably caught it and you're screaming at the screen. Back here, I literally was explaining why x is negative 9, but then I wrote down x equals 9. Instead of negative 9. I don't know why I did that. It was a mistake. So we're just going to need to reevaluate at x equals negative 9. We'll see what the y value is. This shouldn't be too bad to correct. So what is y when x is negative 9 is the correct question, not positive 9. So given x minus 2y equals 1, and x is, again, negative 9, here we'll put in negative 9. Okay, so in that case, I will add 9 to both sides. And then 1 plus 9 isn't negative 8, it's 10. Okay. Silly mistake here. So now 10 divided by negative 2 isn't 4, it's negative 5. Okay, so now our solution set is negative 9 comma negative 5. And I apologize for that. It was a typo or a righto, since I'm writing it. And let's check to make sure that's correct, since we obviously had a little error there. That's why we check, okay? Okay, so here we are looking at the equations. Sure enough, negative 9 comma negative 5 is the solution for that system. So it looks like, there, I think you can see it now. We're looking here at the graph, and you can see that the lines cross at negative 9 comma negative 5 for this system of equations. Okay. Okay, so now we're asked to solve using substitution. What does that mean? Well, it's very simple. Okay. Notice that we have y equals negative 4x, and also y equals negative 5x plus 5. And so this is called the law of the excluded middle, or you could say if A equals B and B equals C, then A equals C, right? And the thing that you're getting rid of here is the B. Right, so here's what I'm saying. And using the same rationale. If negative 4x equals y, so negative 4x being A, y being B, and y equals negative 5x plus 5, then negative 4x equals negative 5x plus 5. So we're simply, it's almost as if to make this, to sort of ramify this point, it's almost like we're whiting out the y. And we are setting these two equations equal to one another. This is my curvy equal sign, okay? So just set the equations equal to one another, because y and y, they're the same. So you can do that. So, we'll just write it out. Negative 4x. Suddenly it's just a single variable equation. It's not that big of a deal. And then we'll go back and find y. So negative 4x equals negative 5x plus 5. Okay, so now what? Solve for x on the left side, right? So I'm going to add 5x to both sides. All right, that allows me to cancel over here. And on the left side, I have negative 4x plus 5x gives me just x. X equals, and the only thing left is this constant term, x equals 5. So now we have to go back to one of the y equals. Doesn't matter, you can pick one. The top one seems easier, y equals negative 4x. So again, we say, what is y when x is 5? All right, that's the question that you should be asking in your brain. Okay, so we'll say given what are we given? We're given y equals negative 4x. And we're given that x equals 5. Then we have y equals negative 4, open parentheses, close parentheses. All right. Inside we put 5. That's the x value. Okay, so that's negative 20, right? So y equals negative 20. So we think that the solution to this system is 5, 20, right? So the solution is 5 for the x and negative 20 for the y. 5 comma negative 20. Okay, so can we check that without graphing? Sure. Let's use the bottom equation, this one, just to make sure we're not fooling ourselves with that top equation. So remember, y is negative 20. So we should say, what's our working thesis here? If what? If x is 5 and y is negative 20, then what? Then the equation y equals negative 5x plus 5 should be true. Okay? So let's test it out. All right? So here we go. We're given y equals negative 5x plus 5. And we're given that x equals 5 and y equals negative 20. Okay, so therefore, we'll put in here open parentheses, close parentheses for the y equals negative 5 open parentheses, close parentheses for that x value plus 5. Okay, so I'll use blue for x and red for y. Okay, so for y, that's negative 20. And the x is 5. Okay, so let's work it out. We have negative 20, and we want to know if this is true. It's a question, right? Now we have negative 20 equals negative 25 plus 5. Again, is that true? Well, negative 25 plus 5 is negative 20, so negative 20 equals negative 20. Okay, and that's true by the identity property of equality. Okay. And so this solution here is correct, right? And we could certainly look at it graphed. Okay, there you go. So you see it's 5 comma negative 20 is the intersection point of those two original lines that we were given. So we verified that. Okay, here we are. So number 5, solve the system by substitution. Well, they've really made it easy here. So we can just choose to substitute in y for x or x for y. What do we do here? Well, here's what we do. We have to kind of like you're playing pool. We got to tell it what we're going to do. So we're going to say we are going to substitute, we can just write sub y for every x in the first equation, so EQ1. Okay, so that's what we're going to do. We're just going to plug in a y, because x equals y. This is really, it's almost such a simple problem that it might confuse you. But since x equals y, I'm just going to place y where I see an x, like right there. Okay, there's only one place, so I wrote every x, but there's just one. So we'll say, okay, fine, given negative 6x minus 5y equals 11, and x equals y, then we have negative 6, open parentheses, close parentheses, minus 5y equals 11. Okay. All right, so what goes in there? Well, that y goes in right here. So not a number, but a letter. And so now we have negative 6y minus 5y. So let's write that out. Negative 6y minus 5y equals 11. Okay, so negative 6y minus 5y equals negative 11y. Equals 11. Okay. I think we all know where this is going. We're going to divide both sides by negative 11. And I've got something divided by itself, those cancel, y equals, and then I've got something divided by the negative version of itself is just going to be negative 1. So y equals negative 1. Okay, so we've got part of our solution. Go back up here and we can put solution . Okay, well, part of that solution is the y value, which we now know is negative 1, or we think. We'll trust but verify, as President Reagan said. Okay, so now what do we do? Okay, well, we just asked that question. What is x when y is negative 1? All right. This is the simplest equation, you know. So let's go back here. And we follow our procedure even when you think you can do it in your head. We ask the question in your head, you know, but you should probably write this down. I mean, I'm writing it down. What is x when y is negative 1? Question mark. Okay. Well, one of our equations was x equals y. So given x equals y and y equals -1, then x equals open parentheses, close parentheses, and then here we put -1. Okay. Now I'm going to show you a new symbol. You should get used to this symbol. Therefore, so see those 3 dots? It means therefore. Those 3 dots means therefore. Please get used to this. This way we don't always have to write out therefore. Okay. Now, let's zoom back out. All right. So therefore, x equals -1. Okay, so we go back up here and put -1. And it's easy enough to prove that, right? Because we just need to check this. Is very simple. What's the check? The check is if x and y are both -1, then x equals y is true. Okay, well, is that the case? You know, we just say -1 equals -1. That's true, okay, by the identity property of equality. Okay, so we were correct about our solution. Now we can look at it on a graph. So here's the graph of the 2 equations, and we see indeed -1, -1 is the solution for that system. Okay, number 6. Now we finally get into a situation where this gets a little bit more interesting. It's saying solve the system by substitution, and x is given as something a little bit more interesting than just y. Okay, so we're going to substitute in 2y plus 6 for x in equation 1. We have to tell the reader what we're planning to do here. Okay, so what we're planning to do is, and now I'm going to introduce another symbol for you. Okay, so you can start writing like a mathematician. Here's the symbol. It'll resolve. Let's see. Okay, this symbol is the upside down version of the therefore symbol. Okay, notice the difference. Okay, this just means since Okay, it could also mean because. Okay, either one. So let's zoom back out. Okay, so since x equals 2y plus 6, we will substitute two y plus 6 for all x, okay, all x's in EQ1. Okay, and this is EQ1. All right, so let's proceed. So that's what we're going to do. All right, so given (8x minus 5y equals 37, and x equals 2y plus 6, okay, we have, I'm going to move this, I know I'm going to have to fit this whole expression inside where the x is. So in order to keep this equation lined up like that, I'm going to move the 8 over here and then put this huge open parentheses basically, and then minus 5y equals 37. Okay, now what goes in here? This goes in here. 2y plus 6. Okay, so I'm going to put in here 2y plus 6. And now we can, proceed like with the regular problem. The first step is going to be to distribute, multiply the 8 through all the terms there. So 8 times 2y is 16y. Eight times 6 is 48. And then the minus 5y comes down. Okay, and that's equal to 37. Okay, so now what? Well, you can either combine like terms. In fact, let's just do that. So I've got like terms here. I've got 16y and negative 5y. When I put them together, add them up, 16 minus 5 is 11, so I get positive 11y So I have 11y plus 48 equals 37. Okay, so now what? Well, we're trying to get y by itself, right? So subtract 48 from both sides. On the left side, that cancels out. And I've got 11y by itself on the left. Okay, and then in order to do this subtraction, I need to kind of flip this in side work. Okay, and go over here and say like, okay, 48 minus 37 and make the answer negative. Okay, so that's going to be 1, 1, negative. Negative 11. Okay, so here we go again, right? We're just going to divide both sides by 11. And on the left, the 11's cancel, leaving y by itself. And then I have negative something divided by itself. So that'll be negative 1. So y is negative 1. So we have part of our solution. Our solution is a pair of coordinates, and the y value of the solution is negative 1. Okay, so now going back up here, I can use this equation to solve for x. So x equals 2 times negative 1 plus 6. So I'm going to do. So now, say, what is my question? My question is, what is x when y is negative 1? Okay? And we've got that given equation. So we're given that x equals 2y plus 6. And we're given that y equals negative 1. Okay, so what we'll do now is plug in negative 1 for y. So we'll have x equals 2, open parentheses, close parentheses, plus 6. And then plug in negative 1 for the y value and evaluate. Okay, x equals 2 times 1 is negative 2 plus 6, and negative 2 plus 6 is positive 4. So x equals 4. Okay, so going back up here, we write x equals 4. All right, and let's double check that work to make sure it's correct. We'll show it to you on a graph. And there you go. You can see that that is indeed where the equation crosses. 4, -1 for that system. Now, number 7 should seem simple at this point, right? Because we've been doing it algebraically. Now we get to graph and just see where they cross. So first, I usually like to put colors next to the lines. So the first equation will be red. I've got a y-intercept at -1. So let's go put a dot there. And then my slope is 2. So up 2 over 1, 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 up 2 over 1. Okay. And so I'm going to plot in that line now. Okay, so there's that equation, y equals 2x minus 1. And now y equals -3x minus 6, so that's going to be a downward sloping line. It's got a y-intercept at -6, so we'll go put a dot right there. And now it's telling me that the slope is -3, so that's fall 3, run right 1. Okay, so from -6, I go down 1, 2, 3 over 1. Okay. Now that's not enough points to make it line, so we can also go up 1, 2, 3 over 1. And there I see I've hit the intersection point. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay, so you see I've already got my intersection point at -1, -3. But we'll go ahead and draw this line in. Okay, so there's my 2 lines graphed. And yes, the intersection point is right here. So I'm going to circle this and identify it very clearly. This is my intersection point, and the coordinates are -1, -3. So it's -1, -3. And that is the solution. Okay. And that is how you do number 7. Number 8 is exactly the same. We're just going to graph this. I'll choose red here and blue here. For the red one, I've got a y-intercept at 8. And then I've got a -1 over 2 slope. So that's down 1 over 2. 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 Okay. So I got a whole bunch of points there I can use to plot my line in. Okay. So there's the red equation. And now the blue equation. Okay, 2x minus 7. So way down here to minus 7, we've got our y-intercept. And then it's 2x. So up to over 1. Okay? So up to over 1. Up to over 1. Up to over 1. Up 1, up 2 over 1. Up 2 over 1. Up 2 over 1. There's the intersection point. Right there. Up 2 over 1. Up 2 over 1. Okay. See, actually, by plotting in all the slope points, I find the intersection point already. Makes life a lot easier. Okay. You want to make sure that your lines extend beyond the edge of the graph and that you put arrowheads there. And so now we identify the intersection point as the solution to the system of linear equations. So it's this point right here, and that's at 6, 5. Okay, so the solution is at 6, 5. 6 on the x-axis, 5 on the y-axis. Okay. Okay, so here we are with another problem where we're going to solve by graphing, but the only difference is the second equation is in standard form. We need to put it in slope-intercept form first. So we just have to do a little bit of manipulation here. Subtract 2x from both sides. All right. That'll give me negative y equals negative 2x plus 6. And now I'm essentially going to divide everything by negative 1. Okay, so divide, divide, divide. Negative 1, negative 1, negative 1. And that cancels out the negatives. I have y by itself. Y equals, and negative 2 over negative 1 is just 2. 2x. And then 6 divided by negative 1 is minus 6. So y equals 2x minus 6. Those are my two equations, and we'll graph. Again, the first one we'll graph in red, and the second one we'll graph in blue. Okay? On the first graph, I have a y-intercept at 1. And the slope is telling me fall 1, run 3. So down 1, right 3. Down 1, right 1, 2, 3. Down 1, right 1, 2, 3. Down 1, 1, 2, 3. We can go backwards. Up 1, left 1, 2, 3. Up 1, left 1, 2, 3. . up left 1, 2, 3. Okay, so there I've plotted all the points that I can on the coordinate plane, and we'll now attempt to graph them. Okay, so there's the red line. Okay, so now we're going to graph the blue line. I've got an y-intercept at -6. So come down here and put a blue dot there at -6. Okay, and then the slope is 2, so up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1, there's the intersection at 3, 0. See? Up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So we can plot this line in here. Okay, so that's the second line, and the point of intersection is right here. We can little arrow here and say that the solution is 3, 0. Okay, so the solution is 3 on the x, 0 on the y. Okay. Moving on to number 10. Same situation. They give us one in slope-intercept form and one in standard form, so they just want us to do this minimal amount of work here to get this thing into slope-intercept form. So y is equal to -2x minus 1. And just to make this look the same, y is equal to x plus 8. All right, those are my two equations. And again, first in red, second in blue. So let's graph y equals x plus 8. So I've got 8 as my y-intercept. And it's x, so it's just 1 up 1 over 1. So I can just make these diagonal boxes because I'm just going up 1 over 1, right? So it's a 45-degree line, pretty simple to graph. Okay, so there's the red line graphed. Now the blue line, y-intercept at -1 and then down 2 over 1 for slope. So first y-intercept at -1. And then it's down 2 over 1. So down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. And then we can go backwards and see if we can hit the intersection. We can go up to left 1. Up to left 1. Up to left 1. There's the interception right there, you see? That's going to be at -3, 5. Up to left 1. Up to left 1. Okay, so now I can plot in the blue line. Okay. So there we go. And what we're going to do now is just circle this. Okay. And so what are the coordinates there? -3, 5. Okay. So we can come over here and write solution -3, 5. Okay. All right. Okay, now we come on to these word problems, which admittedly they seem at first impossible. I often mess them up. So hopefully I'll get this right. But there's kind of a pattern. Once you do about 1,000 of these, you start to get the idea. What they usually give you is some, like Jordan can do 20 shirts per hour. Sydney can do 25 per hour. Okay? Jordan worked 4 hours more than Sydney, and they ironed 350 shirts between them. Okay, so what we should write down is like the equation. We could say Jordan. We have to give some letters to this, right? Jordan will equal J, and that's hours worked, and then Sydney hours will equal S. Okay, so Jordan irons 20 shirts per hour. Okay, so 20J, right? Sydney 25 shirts per hour. So one thing we can write down is we can say 20 shirts per hour for Jordan. I guess I'll use lowercase j. Plus $25 shirts per hour S equals 350 shirts. Okay. Now we're also told that Jordan works 4 hours more than Sydney. So we're told that J equals 4 plus S. So 4 plus Sydney hours. Okay. So now we have a system, right? If I subtract S from both sides, and do a little rearranging, I'll have this right here. I'll have 20J plus 25S equals 350. And then this j goes underneath here. And we could say 1j. And then minus s, negative 1s equals 4. Okay, so now I've got a system, right? Now you can work this just like any other system. So what would be advantageous here? I suppose I could have used substitution right there and just plugged in 4 plus s for j, but I was going to do elimination. So I was going to multiply the bottom equation by negative, what do I want to do here? I'll multiply the bottom equation by, no, I'll eliminate s and multiply the bottom equation by 25. Okay, so I'll have 20j plus 25s equals 350. And then on the bottom, I'll have 25j minus 25s equals 100. Okay, well now I can eliminate the s using addition. And I see that I've got 45j equals 450. 45j equals 450. Dividing by 45. I get j equals 10. Okay, so if my solution is going to be j comma s, then I've got j. J is 10. Okay, so now we just need to plug in that to one of the original equations. So this one's the easiest one, j equals 4 plus s. So we can find that out. We can say what is the question we're trying to answer? The question we're trying to answer is, what is s when j is 10? Okay, that's the question. So given j equals 4 plus s and j equals 10, we have 10 equals 4 plus s, and if we subtract 4 from both sides, we will have 6 6 equals S. Okay, so over here we can put 6. Now, does that make sense? It says here, Jordan worked 4 more hours than Sydney. Look, so Sydney worked 6 hours, Jordan worked 10 hours, Jordan worked 4 more hours. So that should give you some confidence that your answer is correct, because it makes sense in the context of the word problem. So yeah, that is, the worst word problems are tricky, but that's how you work that word problem. Okay, here we are on number 12, and it looks like a block of text, right? So this is Delta Math giving you this really what I think is just taking up valuable white space. This would be easier to understand on Delta. It's like drop-down menus and stuff, but I think it's just clogging up the space, so I'm going to cover that with one of these little stickers, because I don't need all that. Okay, so here we go. This works better for me. All right, so Mason, blah, blah, blah. Okay, what are our variables? One of them is the commercial, and then one of them is the movie. Okay? So it says here he earns 30 per commercial and 80 per movie. It also says he earns a total of 470 on 9 commercials and movies. So here's how you work these. You say, let's use the color. So the first equation is going to be 30C plus 80M Okay. And then I got to figure out what this equals for a second. But we can say is, yeah, 30C. Okay, so that's it. So 30C plus 80M equals $470. Okay. And then we write down C plus M equals 9. Because it says he did a total of 9 commercials and movies. There's that other number. I was looking for that second number. They always give you 2. Okay, so now we can solve this. You know, how do you want to proceed here? I think the easiest thing to do would be to multiply this left equation here by negative 30. Okay, so I'm going to multiply this by negative 30. And then I'll have to rewrite 30C plus 80M equals 470. And then I've got negative 30C minus 30M equals negative 270. Okay. Sorry you couldn't see any of that. That's it. I was just distribute multiplying the negative 30. And now we can eliminate by addition. Okay. Again, if this helps you, break it into columns like that. And these cancel out. So I've got 80 minus 30, that's going to be 50M equals, and then 470 minus 270 is just 200. And so you see the math looked hard, but now it isn't. We divide both by 50. Cancel, cancel. And then you can cancel the zeros. 20 divided by 5 is 4. So M equals 4. Okay, so he did 4 movies. All right, well, how many commercials did he do? Well, we have an equation here, C plus M equals 9. So part of our solution, so we've got part of our solution. And it says commercials and movies. The problem lists here commercials and movies. So we'll do C, comma, M. So C, comma, M. And so the M value is known to be 4. Okay. So now the question we're asking is, what is C when M is 4? Okay, what is C when M is 4? Well, we have this equation, C plus M equals 9. So we can say given C plus M equals 9 and M equals 4, then C plus 4 equals 9. And subtracting C from both sides, I'm sorry, subtracting 4 from both sides gives us C equals 5. Okay, so he did 5 commercials and 4 movies. And we should do a sanity check. First of all, 5 plus 4 equals 9. But how about 30 times 5? That's 150. Okay? Plus 80 times 4, that's 320. And just make sure that that equals 470. 470. Okay, so it checks out. Yeah. So we did it right. You know, that's how you know you did it right. Okay, so that's the end of number 12. Okay, so here we are on number 13. This is the last of the word problems. And let's see what's going on with the drama club. The drama club is selling tickets to raise money. Okay, whatever. Each student ticket. Okay, so there you're already starting to see. We got S is 6 and A is 9. And then the revenue, this is going to be how much they earned, because this has got dollars from 98 total tickets. So it's going to be S plus A equals 98. It's one of the equations. And then 6S plus 9A equals 747 is the other one. So let's write this out. You've got 6S plus 9A equals 747. Okay, and then down here it tells you the total number of tickets sold. And this is the part that is hardest for people to get. You're supposed to just say S plus A equals 98. Because it's like the top equation's money, the bottom equation is the total number of tickets, right? So once again, let's eliminate the A, since we've been eliminating the S, or the left one. So we'll multiply everything by -9. And okay. Okay, so let's rewrite. I'll have 6S plus 9A equals 747. And then down here I'll have -9S minus 9A equals, and then I need to do inside work 98 times 9, because I have no idea what it is. 98 times 9, and then make the answer negative. So that's going to be 2, 7. Okay, so 81 plus 7 is 88. So that's 8, 8, 2, negative. So this is -882. Okay. All right, so now we can add, and if you put these in columns, you'll see that you can completely eliminate the A. So we solved for S now. Okay, so 6 minus 9 is -3S. And then let's figure this out. We're going to have to do 882 minus 747. And then make the answer negative, okay? So borrow here, 7, 12, 5, 3, 1. Okay, so I've got -3S equals -135. Okay, so 1 plus 3 is 4. 4 plus 5 is 9. This 135 is divisible by 3. So let's divide. First, let's write this a little bit nicer. We got negative 3s equals negative 135. Okay. So if you want to take 135, if you can't do this in your head, do it long division style. Just divide by 3. 3 goes into 13 4 times. That's 12. Leaves 1 as a remainder, 15. 3 goes into 15 5 times. Okay? And so when we divide both sides by negative 3, we're going to get s equals positive 45. Okay? So now we have part of our solution. So this was student, comma, so solution. And then we have S, comma, A, like student and adult. So the coordinates here are 45, comma, something. Well, S plus A equals 98. That's the easy one, right? So again, we're asking the question, what is A when S is 45? Okay. Well, given S plus A equals 98, and S is 45, okay, then we could say 45 plus A equals 98. And we just subtract 45 from both sides. Cancel. And then A equals 8 minus 5 is 3. 9 minus 4 is 5. 53. Okay, so A is 53. And we should probably check, does 45 plus 53 equal 98? Yes, it does. And I'll just, to save ourselves a little time, we really shouldn't be doing this. In fact, I almost don't want to do that. So the other thing we could do is we could check the top equation to make sure that works. So 45 times 6. Okay, so that's going to be 270, right? Plus, and then 53 times 9, I've got no idea. 53 times 9. 450 plus 27. 477. Is that right? So it's going to be 27 to 45, 46, 47. Yeah. Okay, so 270 plus 477. That's going to be 7, 14, and then 747. You see, we got 747. So the top equation worked too. We were correct. So that's how we just double checked ourselves in two different ways to make sure we're correct there on number 13. Okay, here on number 14, we're asked to solve the system of inequalities and then state the coordinates of a point in the solution set. So we just need to state the coordinates of one point in the solution set. So how do we graph these linear inequalities again? Well, it's really quite simple. We just treat them like they're equations, only for this greater than symbol, we're going to be using I noticed that we have a negative slope, so this is going to look kind of like this. Dashed line, open circles, okay, wherever you plot points, open circles, and then the shading will be above the line, okay? Same thing here, only the slope will be positive. But otherwise, we treat it just like a linear equation. So we start with or we'll make this one the red and this one the blue. Okay, so with my red, I'm going to start at -3. So down here, -3. And I'm going to put an open circle there. And then I'm going to go down 1 over 2. Down 1 over 2, down 1 over 2. Down 1 over 2. There's a point. Down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. Okay, so I'm starting to feel pretty confident about that line. I just want to do a couple. Up 1 over 2. 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 All right. So there's all the points, okay? So now we can dash this in. Okay, arrowheads go on the end. And then what we do is we shade, and to facilitate that shading, I'm going to use, now am I shading above or below? I'm shading above, right? So I will use this highlighter. We do not want to touch this line, right? So I want to be careful not to touch the line. So okay, we can get a little bit closer to the line there. Okay, so now I've shaded in that inequality. Now it's time to do the blue. Okay, so the blue starts at +6, and that's going to be an open circle, and it goes up 1 over 1, up 1 over. Okay, so it's just one of these 45-degree lines. kind of like that, okay? And then we can draw in the dashed 1 dash 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 dash. Okay, so arrowhead, arrowhead, and now I'm shading above that line. Okay, so what we're looking for is the region of double shading. So here I'm shading okay, so do you see the region where it's double shaded? Right here. Okay, just in case that's not super clear, I'm going to outline it in Sharpie, but I don't want to mess up. I don't want it to bleed through onto something important. So this is my solution region. Okay, that whole area in there. And so you just have to pick a point inside that zone, okay? And I mean, pick something easy, -6, comma 6, right? So that puts me right here. So we can put a dot right there, okay, and say that's my, this is going to be -6, comma 6. That's going to be my solution. I've stated the coordinates of a point in the solution set. So for my answer, I could just leave it right there, but I could put it down here as well and say -6, comma 6 is a point in the solution set. Okay. All right, so same thing here. So now this time the less than symbol, that's going to be a, I see I have a negative slope here, dashed line, and open circles with the shading below. Okay, the shading's below. So otherwise plotting as if they were regular lines. So I have, we'll call this one the red and this one the blue. So for the red, I've got a y-intercept at 1, open circle, and then I'm going down 1 over 1. So that's just going to be like this. See what's going on here? And then okay, once you get the idea, you can come in and sort of dash in your line. And then are we shading above or below? We're shading below, less than, okay? So again, ruler very important. Don't touch the line. Okay, so that's that shaded region. Now we're going to do the second equation. I have a y-intercept at 7, open circle at 7, and it's up 1 over 5. So up 1 over 1, 2, 3, 4, 5. Up 1 over 1, 2, 3, 4, 5. And I need to go down 1 over 1, 2, 3, 4, 5. Down 1 over 1, 2, 3, 4, 5. Okay, so there's all the points that I can plot. And we're going to draw a dotted line, or dash line anyway. Okay. There it is, and we're shading below, okay? So we take the blue, and we shade the whole thing below. And you should see that overlapping region. That's the solution region. Okay. Okay, so you see the double shaded region is the solution region. And let me define that with the Sharpie so it's really clear. That is the solution region right there, okay? So we just plot a point in that solution region. And how about -5, comma, -5? That works. Okay, so that's right there. Let's say -5, comma, -5. That's a point in the solution region. Okay, and we should probably write that out. Okay, you just tell the viewer that -5, comma, -5 is a point in the solution set. All right, and that brings us to the end of our journey. And as we step back and look at all of our work, You should feel quite proud. You did a lot of hard work. And there you go. That is the conclusion of Write and Solve Systems of Equations, TEKS A2I and A5C. Great work, folks. Thanks for watching.